Hey, we're live. Would anyone like to say something like, hello, Mom? Folks back home? No? Okay. What was that, Keithling? Keithling says hi. Hi, Mom. Oh, yeah. If you got to get on Tech 21, you have to re-accept the certificate, supposedly. So it'll ask you and say, yes, I accept the certificate. Okay? I think so. It's supposed to. And if you want, you could print out the certificate and frame it and put it on your wall at home. Okay? Look what I did. I accepted the Tech 21 licensing agreement. Okay, we are on example 11, putting it all together. It says, draw the graph of function f of x on the interval from -5 inclusive to infinity with the following characteristics. So if you have a function like this, f of x is the name, all you need to do is make sure that your graph meets the requirements that are indicated. And then other than that, it just has to pass the vertical line test. So you have a little bit of flexibility. So the first thing I would do is go ahead and create a y-axis and an x-axis, and then pick a flavor. That's the hardest part, especially with all these new flavors. What should we use? Burnt orange, good. It's fall, right? Everything's pumpkin spice now, so it'll be pumpkin spice mathematics. There is. Oh, yeah. It all started with Starbucks like 15, 12 years ago. They did the pumpkin spice latte, and now everything's pumpkin. I even have pumpkin spice beard cream that my wife got me. So, like, all day long, I'm trying to eat my face. I'm like, that's delicious. Ooh, yeah, you can get pumpkin spice soda at H-E-B for a limited time, folks. Probably by January, it'll be gone. Now, what's really good is the pumpkin spice eggnog. That's like double seasonal. Seasonal pumpkin, seasonal eggnog, put them together. Anyway, I don't know how we get off track. I'll blame you all. Okay. We are talking about what x value to start. -3. So I'm going to come over here and just put a -3. And I just need to make sure what is indicated here is happening at -3. So as I come in from the left, I need to land at -2, but that's also where the bridge is, right? So I got a road coming in from the left that goes to the y value -2, and it's also the function value, so that's also where the bridge is. So right here at -2, maybe I'll take my -3 label and put it up here now so I don't interfere with my point. So there's the point, and then I know it's just coming in like that. So that's all I'm going to do for now. Something like that. What happens to the left of there, I don't know yet. All right, now look at the other side. As I approach -3 from the right, I'm going to infinity. Whoa. So what must live there that forces the y values to increase without bound? There's a vertical asymptote. Now notice it only affects the graph on the right-hand side. This would be kind of a strange discontinuity because it would appear to be a jump discontinuity, but there's also a vertical asymptote there. Kind of weird. Frankenstein's monster, remember, piecewise function. Okay, so I'm done with these. That's what's happening at -3. Now it says f of 0 equals 0, which is also the general limit. So what do we know about a function if the function value is equal to the general limit? What can we say about the function at that point? It's continuous. Because remember, the general limit talks about both roads. So both roads are lining up and going to 0. The function value is going to 0. So we know that this passes through the origin. And I'll just kind of draw it like that. Maybe just going through somehow like that. Not too far on either side. All right, now I'm looking at +3. I'm done with all this. Going to +3. +3 is going to be about right here. And it says the limit from the left is 4. So I'm going to come up here and call that 4. And it looks like I'll just put an open circle there and maybe do that. And the limit from the right is 1. So I need to label this as 1. And maybe I'll move this 3 here down to the bottom for the label. And the limit from the right is 1. So then it's going to look something like that. Now it says f of 3 is -1. Well, by golly, that's going to be right up here, -1. And I'm going to put an open circle, or a solid dot, sorry, right there. So this is like a bridge project disaster, isn't it? 3 different contractors, one for each road and one for the bridge. And they're like, I know, let's build it here. Yeah, I'll build this here. Hey, put the bridge here. That's crazy looking, okay? And they're all going to want to get paid, believe it or not. Okay, so that takes care of what's happening at 3. And then the only other thing they're specifying is, as we go out to the right, we got to approach 2. So 2, I'm going to go ahead and say is right here. And if I'm going to be approaching 2 as I go to the right, that has to be a what? Horizontal asymptote. So I'm going to draw it kind of horizontal with 2. Now all I got to do is come in and fill the voids in between. And this is where you can get creative. So let's go ahead and finish it. I'm going from -5 to infinity. So what I'm going to do is come over here and call this -5, and that's where I'm going to stop. So instead of going straight up, I'm going to dance around a little bit and stop down there. Boy, that was fun. Answers may vary. You could even cross the x-axis if you want. This is what we call the local behavior. See how crazy it is? Local behavior. Drunk people on the river. Local behavior. Craziness going on near the y-axis. And then from here, it looks like I might just connect that, but no, I'll bounce off the x-axis first. Boing, and then I'll connect. Just because it's more fun, right? That's why people go to that trampoline world out there on 35. What's it called? The jump castle? Bouncing trampoline world? Spring-loaded. That's what it's called. Yeah. It's fun to bounce, right? Boing off the x-axis. And then from here, I need to connect up to there, so how about slither like a snake, kind of snake it up there. And then I have a jump here, and now I need to come off from this 3 and approach 2. So as I do that, I can either come down from above like that and just kind of level off. I could even come down like that and approach it from below like that. Or are we allowed to cross the horizontal asymptote? Yeah, we've seen that behavior. Let's do it like this. I'm going to do it like this. I'm going to oscillate by less and less and less and make it look like it's outlining. There is your end behavior model, folks, your end behavior model. Coach Fair. All right, and there we go. Now we'll label this as f of x. And we're done. Answers may vary. Well, no, it's just customary somewhere when you have a graph to label what it is. Give it the name. So you're like, hey, that's the graph of Hector. No, that's not Hector. That's F. Right? You name it. It's like putting a tag on a dog, right? Here, puppy, what's your name? It doesn't have a name. Then you start calling it things like Star or Lucky or whatever. Sniffles or Whiskers. Whiskers is a good name. That's a good name for a lot of animals. Whiskers. Whiskers. You can name all of your pets Whiskers. Be kind of confusing. You know George Foreman, the boxer? He has lots of sons. Maybe 3 or 4. Let's say 5. I don't know. You know what every single one of them's first name is? George. You know what his first name is? George. All of his kids are named George. He even has a daughter. Guess what her name is? Georgina, or for short, George. Yeah. So. I don't know. I don't know how that works. I don't know how that works. But I think they all have different middle names. You know, like George 1. So it's George 1, George 2, maybe. I don't know. Possibly. This would not be a very good multiple choice question, would it? No, this would be a grade 3 response type question. Putting it all together. All right. We got 10 minutes. Let's do this last one here very quickly. Summary. Example 12 is summary. If the limit as x goes to c from the left equals f of c, which equals the limit from the right, then what can we say about the function at x equals c? Continuous. Yeah, f is continuous at x equals c. Exclamation point. I just feel like you have to put one there. It's exciting, right? Road, bridge, road. All connected. Family safe. If the limit as x goes to c from the left equals the limit of c approaches c from the right, then what can we say about the general limit? Then it exists, right? And it equals the limit as x approaches c from the left, which equals, let's call that L. How about this? Makes it easier. You could do this. You could label this. You could say if this equals, let's use capital K. Use your own letter. If the limit from the left equals the limit from the right, let's say that they equal K, then the general limit exists and also equals K. That's an easy way to do it, because now you're equating two things to one letter. Now, that's not the continuity argument, right? That's just the argument for the limit existing, the general limit. You have not looked at the bridge, and this is the one that I will warn you. When I ask you to use a 3-step definition of continuity, some people do this, and this alone. They say the limit from the left is 5, the limit from the right is 5, therefore the limit is 5, and the function is continuous at x equals c. Is that correct? You have never considered the bridge. You never considered the bridge. So we had that conversation yesterday. I'm not traveling with you. If the limit from the left does not equal the limit from the right, but they both exist, I need to add that in there. But they both exist. What type of discontinuity do we have? If the limit from the left exists, the limit from the right exists, but they're different, what type is a jump? We have a jump at x equals c. F has a jump. You want to speak in complete sentences there. If the limit from the left equals the limit from the right, but neither one of them equals the function value, then what type of discontinuity do we have? Then we have a hole or a removable point. Yeah, F has a. The next one, if you're approaching a specific value, call it C, from the left or the right, and it equals plus or minus infinity, what graphical feature does the graph have at C? VA. VA at x equals C. What's the proper name for a vertical asymptote? Very good. An infinite non-removable discontinuity, or an infinite non-removable. Either way, you can put the describers, the adjectives in either order, because adjectives are commutative. You can commute adjectives. All right, then the last one here. If the limit as x goes to infinity equals L, or negative infinity equals L, what graphical feature do we have as a result? Horizontal asymptote at y equals L. Is there a proper name for the horizontal asymptote, like non-removable, infinite? No, it's not a discontinuity. Okay, sure. Yeah, it's just some finite y value. It's the same thing that I threw up here as k. It just has to be something finite. Okay, if it's non-finite, it's infinite, and there's no horizontal asymptote. Okay, so that completes the notes then. Let's go ahead and talk about the test. All right, the test. It's tomorrow. Y'all are going to have a good